Okay, so on my previous video, I presented ways how the first and the second derivatives are used to trace the graph of a function. Again, the first derivative test is used to determine whether the function is increasing or decreasing. And also, the first derivative is used to find the relative minimum and relative maximum of the given function, while it is verified by applying the second derivative test. Also, the second derivative test allows us to determine whether the function is concave upward and concave downward by getting its point of inflection. So in this video, I'll be presenting you some problems with regards to finding the maxima, minima, and the point of inflection of a given function. Okay, to recall, here are the summary of the theorems I presented on my previous video. We say that f of x is increasing at x equals c whenever f prime of c is positive, and that is decreasing whenever f prime of c is negative. And the function f of x is at maximum at x equals c whenever f prime of z equals 0, and the f double prime of c is negative, and it is at minimum whenever f prime of c equals 0 and f double prime of c is positive, and it's concave upward whenever f double prime of c is positive and concave downward whenever f double prime of c is negative. And finally, f of x has a point of inflection at x equals c whenever f double prime of c equals 0, and f double prime of x changes sign as x increases through c. Okay, so we will be applying this information or this theorem to solve problems related to maxima and minima. Let's take a look at this one. So we wish to find the relative minimum or maximum point or points, and the point of inflection of the function f of x equals x e raised to negative x. So here I'll be giving you several steps on how to solve this kind of problem. The first step is to differentiate the function f of x equals x e to the negative x. So by applying the product rule, so f prime of x equals x times derivative of e to the negative x is negative e to the negative x plus e to the negative x times derivative of x, which is 1. So we shall simply have negative x e to the negative x plus e to the negative x. So this is our f prime of x. And then the next step is to find the critical number. And the critical number is obtained whenever you let f prime of x equal 0. So we shall have 0 equals negative x e to the negative x plus e to the negative x. And then we factor out e to the negative x and we solve for x. So we shall have 0 equals e to the negative x times the quantity negative x plus 1. And then we have 0 equals e to the negative x, or 0 equals negative x plus 1. And this equation, 0 equals negative x, will give us an extraneous solution. And therefore, we say that x equals 1. Okay. And then the third step is to find the critical point. And the critical point is obtained whenever you replace x on the given function by 1. So we will be looking for f1 equals 1 times e to the negative 1. So we shall have 1 over e. And the point 1 over e is our critical point. And this is critical point because we do not know yet whether this is relative minimum or relative maximum. And to determine whether this point is relative minimum or relative maximum, then we will be applying the second derivative test. And by the second derivative test, we shall differentiate f prime of x. So we have f prime of x equals, I will factor out e to the negative x here. E to the negative x times negative x plus 1. And then differentiating f double prime of x by using the derivative of product. So we have e to the negative x times negative 1 plus negative x plus 1 times the derivative of e to the negative x is negative e to the negative x. So we shall have negative e to the negative x plus x e to the negative x minus e to the negative x, or that will become x e to the negative x minus 2 e to the negative x. So here we go. And then to determine whether this point is a relative minimum or relative maximum, we will replace x here by 1. So we shall have f double prime of 1 equals 1 times e to the negative 1 minus 2 times e to the negative 1. And then this is equal to e to the negative 1 minus 2e to the negative 1. And that's negative e to the negative 1. So we shall have negative 1 over e. And then since negative 1 over e is less than 0, then the point 1 over e, based on our theorem, is a relative maximum point. And then the next thing to do is to find the point of inflection. And then the point of inflection is obtained when we let f double prime of x equals 0, and then you solve for x. So we shall have, okay, this is our f double prime, the second derivative, and then we let this to be 0. So you have x e to the negative x minus 2e to the negative x. And then again, we shall factor out e to the negative x, and then we solve for x. So we shall have 0 equals e to the negative x times the quantity x minus 2, and then 0 equals e to the negative x, or 0 equals x minus 2. Again, this will give us an extraneous solution. Therefore, x equals 2. And then to find the point, we shall replace x on the original given by 2. So we shall have f of 2 equals 2 times e to the negative 2, or that's 2 over e squared. And therefore, the point 2 over e squared is a point of inflection. Problem number 2. And by the way, this is the graph of the function f of x equals x e to the negative x. And then we proceed with problem number 2. Say we wish to find the point of inflection of the curve defined by xy equals 4 ln 1 half x. Okay, to easily facilitate this, the derivative of this function, okay, we explicitly describe y in terms of x. So we have y equals 4 over x ln 1 half x. And then we just divide everything by x. So we arrive at y equals 4 over x ln 1 half x. And then to find y prime, we use derivative of product. So we have 4 over x times derivative of ln 1 half x. Then we use du over u. So you have derivative of 1 half x is 1 half, and then all over u, which is 1 half x. So we have 1 over x alone. So we have 1 over x plus ln 1 half x times derivative of 4 over x is negative 4 over x squared. Yeah, and then we shall have this, okay? That's 4 over x times 1 over x plus ln 1 half x times negative 4 over x squared. Simplifying, we shall have 4 over x squared, and then minus 4 over x squared ln 1 half x, and then I will factor out 4 over x squared, and then we only have y prime equals 4 over x squared times the quantity 1 minus ln 1 half x. And then since we're looking for the second, for the point of inflection, we use the second derivative test, okay? So differentiating this again, y double prime, we have by derivative of product again, 4 over x squared times derivative of 1 minus ln 1 half x is negative 1 over x plus 1 minus ln 1 half x times derivative of 4 over x squared is negative 8 over x cubed. And then we just simplify this part. We have y double prime equals negative 4 over x cubed. That's the product of these two. And then you just write this in front. So you shall have negative 8 over x cubed times the quantity 1 minus ln 1 half x. And then the next thing to do is to let the second derivative y double prime equal to 0, because the point of inflection is obtained whenever we let the second derivative equal to 0, and then we solve for x. So you have 0 equals negative 4 over x cubed minus 8 over x cubed times the quantity 1 minus ln 1 half x. And then what I'm going to do is I will factor out negative 4 over x cubed. So that leads me to this, 0 equals negative 4 over x cubed times the quantity 1 plus 2 times the quantity 1 minus ln 1 half x. And then the next thing to do is to introduce this to each term inside. So I shall have 0 equals negative 4 over x cubed, or 0 equals 1 plus 2 times 1, okay, minus ln 1 half x. Or again, this will give us an extraneous solution. Then the only thing left to do is to simplify this part. So you have 0 equals 2 times 1 is 2, then plus 1, that will give us 3. And then 2 times negative 1 half ln 1 half x is negative 2 ln 1 half x. And then to do this, this can be written of the form 2 ln 1 half x equals 3, or 3 halves equals ln 1 half x. Okay, and then to look for x, we express this exponentially as e raised to 3 halves equals e raised to ln 1 half x. And we know that e to the ln 1 half x is simply 1 half x. So you have e raised to 3 halves equals 1 half x. And finally, x equals 2e raised to 3 halves. So we now have our x equal to 2e raised to 3 halves. And then the next thing to do is to get the corresponding value of y for whenever x is 2e raised to 3 halves. So if x equals 2e raised to 3 halves, so we shall have x is replaced by 2e raised to 3 halves times y equals 4 ln 1 half times 2e raised to 3 halves. And 1 half times 2e raised to 3 halves is equal to e raised to 3 halves. So we only have 2e raised to 3 halves times y equals 4 ln e raised to 3 halves. And you know that ln e raised to 3 halves is 3 halves alone by applying the properties of logarithmic function. And then we shall have 2e raised to 3 halves y equals 4 times 3 halves, and this is now equal to 6. So we shall have 2e raised to 3 halves y equals 6, and y is equal to 3 over e raised to 3 halves. And therefore, the point of inflection is given by 2e raised to 3 halves, 3 over e raised to 3 halves. Problem number 3. Find the relative minimum or maximum point or points for f of x equals ln 2x minus x squared. Okay, so step 1 again, differentiate the function. So we have derivative of 2x minus x squared is 2 minus 2x all over 2x minus x squared. We are using du over u. And then the next thing to do is to get the critical number. So again, you let this to become 0. So 0 equals 2 minus 2x all over 2x minus x squared. And then by cross multiplication, you only left with 0 equals 2 minus 2x. And then therefore x equals 1. Okay, when x is 1, okay, we look for the corresponding value of y. So get the critical point. So you have, if x equals 1, then we have f of 1 equals ln 2 times 1 minus 1 square. And you know that 2 times 1 is 2 minus 1, and this is equal to 1. So we have ln 1, and ln 1 is equal to 0. Therefore, the critical point is 1, 0. And then the next thing to do is to verify whether this 1, 0 is relative minimum or relative maximum. And that can be done by getting the second derivative. Okay, by second derivative test, we use the derivative of quotient here. So this is our u, and this is our v. So you have v, that's 2x minus x squared, times derivative of the numerator, that's negative 2, minus the numerator, that's 2 minus 2x, times the derivative of the denominator, that's 2 minus 2x. And then to simplify, we just multiply this. So that's negative 2 times the quantity 2x minus x squared minus 2 minus 2x quantity squared all over 2x minus x squared square. And then to test whether this is relative minimum or maximum, we replace x by 1. So we shall have negative 2 times 1 is 2, then 1 square is 1, minus 2, then 2 times 1 is 2. And we know that this 1 will become 0. So we have, then 2 times 1 is 2, then 1 square is 1. So this is equal to 1, and 2 minus 1 is 1, and then times negative 2 is negative 2. Okay, and since negative 2 is less than 0, then the point 1, 0 is a relative maximum point. Okay, so let's have some more. Okay, find the value of a and b so that the curve y equals ax cubed plus bx squared will have a point of inflection at 1, 2. Okay, so we're looking for the value of a and b, and then the only information we have is that this function y equals ax cubed plus bx squared has a point of inflection at 1, 2. And then the keyword here is point of inflection. Then we need to look for the second derivative. So that's y double prime, because by second derivative test, you can describe the sense of concavity of the function by means of point of inflection. Okay, so we first differentiate y prime equals 3ax squared plus 2bx. And then the second step is to get the second derivative. Y double prime is 6ax plus 2b. Am I right? Yeah. Okay, good. And then since at the point of inflection, 1, 2, y double prime equals 0. So we let y double prime is 0 whenever x equals 1. So using equation 2, okay, so we have 0 equals 6a times, replace this by 1, times 1 plus 2b. And then we have 0 equals 6a plus 2b. And we have here equation 3. And then since this point of inflection 1, 2 is a point of on this curve, then we let x equals 1 and y equals 2. And then we just replace y by 2 and x by 1. So we shall have 2 equals a times 1 cube plus b times 1 square. Yeah. And then we have 2 equals a plus b, and therefore we can say that a equals 2 minus b. And then we will be using this expression to replace a here, so we can get the value of b. So therefore, we shall have 0 equals 6 times 2b, that's a, plus, 6 times 2 minus b plus 2b. And then we introduce 6 each term inside. So that will become 0 equals 12 minus 6b plus 2b. And then you combine these two, and that's negative 4b. And therefore, b equals 3. So we already have our b. And then the next thing to do is to look for a by replacing b by 3. So you have a equals negative 1. And therefore, the function y equals negative x cubed plus 3x squared will have a point of inflection at 1, 2. Okay, let's sum some more. I think this is the last problem. Find the value of a, b, and c so that the curve y equals ax cubed plus bx squared plus cx will have a slope at 4 at its point of inflection, negative 1, negative 5. Okay, so the problem tells us that this curve y equals ax cubed plus bx squared plus cx will have a point of inflection at negative 1, 5, and this function will have a tangent line on its point of inflection whose slope is equal to 4. Okay, so we now have a tangent line and the slope is equal to 4. So again, the first step is to differentiate the function. Y prime equals 3ax squared plus 2bx plus c. And then you get the second derivative that gives you 6ax plus 2b. And then our information tells us that the function has a point of inflection at negative 1, negative 5. And therefore, at that point, y double prime is equal to 0. So we let y double prime equal 0 whenever x equals negative 1. Okay, and then using this equation, so we replace y double prime by 0, then 6a times negative 1 plus 2b. So we have another equation here, 0 equals negative 6a plus 2b. So I'll mark this equation 1, okay? And then since at the point of tangent C, negative 1, negative 5, we can draw a tangent line whose slope is equal to 4. And you know that when we're talking of the tangent line, the slope of the tangent line, we're talking of the first derivative. So we say at negative 1, negative 5, the slope of the tangent line is 4. And therefore, we shall let x equals negative 1 and y prime is 4. Then we use this equation, y prime is 4. Then 3a times negative 1 square plus 2b times negative 1 plus c. And then we can have another equation of the form 4 equals 3a, minus 2b plus c. And I will mark this as equation 2. Okay, another equation is that, another information we can generate from this problem is that this negative 1, negative 5 is a point on the curve. So we shall let x equals negative 1 and y equals negative 5, and then we just replace it here. So we have negative 5 equals a times negative 1 cube plus b times negative 1 square plus c times negative 1. And then you'll have negative 5 equals negative a plus b minus c. And we will mark this as equation 3. And then to look for, we have equation 1, 2, and 3. And then to look for the values of a, b, c. And then we can have this 3 independent equations. And then we will be using this equation to look for the values of a, b, c by systems of linear equation. Then by using equation 2 and 3, we can eliminate c, okay, by adding the two equations. So you have 4 plus negative 5, 3a plus negative a minus 2b plus b, and c plus negative c. And then you have this. So this is our equation 4. So this is negative 1 equals 2a minus b. And then since equation 1 is expressed in terms of a and b, then we can use equation 1 and 4. So that's 0 equals negative 6a plus 2b, and then negative 1 equals 2a minus b. And then to eliminate b, we shall multiply this by 2. And then we can have 0 equals negative 6a plus 2b. Then 2 times negative 1 is negative 2. 2 times 2a is 4a. 2 times negative b is negative 2b. And then adding these two equations, we shall have 0 plus negative 2 equals negative 2. Negative 6a plus 4a is negative 2a. And then this 2 will become 0. So therefore, we can say that a equals 1. Okay, whenever a equals 1, okay, we have negative 1 equals 2a minus b. Okay, and then we replace a by 1. So we have negative 1 equals 2 times 1 minus b. And simplifying and looking for b, b equals 3. And finally, using any of these two equations, okay, so you shall have negative 5 equals negative a plus b minus c, where a is to be replaced by 1 and b is to be replaced by 3. So you have negative 5 equals negative 1 plus 3 minus c. And then negative 5 equals negative 1 plus 3 minus c. Okay, so c equals negative 1 plus 3 plus 5, and therefore c equals 7. So we have a equals 1, b equals 3, and c equals 7. And therefore, the function y equals x cubed plus 3x squared plus 7x will have a point of inflection negative 1, negative 5, and you can draw a tangent line at negative 1, negative 5 whose slope is equal to 4.